Section 8.4. The pressure volume and pressure volume temperature phase diagrams. First, the pressure volume diagram. Well, at a given pressure, let's say, well, this is 1 bar pressure with a very large molar volume. You have a gas. If you compress the gas enough, you may convert the gas to liquid. So this is liquid and gas at constant pressure. If you further compress the mixture of liquid and gas, you get pure liquid, and then you compress it, you get solid, and further compress it, you get solid. This diagram, Pv diagram, is for most substances. Again, for water, you have to swap solid and liquid because the molar volume of ice is greater than the molar volume of liquid water. And then you can, increase the pressure, maybe here, over here. If you increase pressure, you go from gas to actually the supercritical fluid here. So this is supercritical fluid. Okay, and then you further compress the supercritical fluid, it becomes a liquid. Right, and then solid. So that's that. And if we analyze process A, it's to increase the molar volume. First it's solid at very high pressure, very low molar volume, it's solid, and we gradually allow this volume to expand. You get liquid and then gas. How about B? Well, in B, the liquid phase is skipped. You go from solid directly to gas at low enough pressure. So it's more like sublimation here. And then C, you just change the pressure. You hold the volume constant. So first you have this solid plus gas, and again you hold the volume constant. You have a constant volume condition. And then you change the pressure. When you change the pressure, of course, the temperature is going to have to change. So really, this process, you are heating up a constant volume mixture. Okay, so you put ice and water vapor in a container, and then you heat it up, and you get liquid water and gas, and finally you have gas. All right. So those are the descriptions of process A, process B, and process C. Oh, by the way, this process B is very useful in industry. It's called freeze drying. Freeze drying. Okay. So you can actually get rid of water by freezing something wet, and then allow the ice to sublime. Okay, so it's kind of strange. The Pvt phase diagram, you have 3 variables. So it's pressure, it's volume, it's temperature. Actually, this is molar volume. Never use the volume directly, because volume is a extensive property. So even if you hold pressure and temperature constant, I can add more water into this cup of water, and then the volume increases suddenly. So that confuses people. So why don't you just use molar volume here, or you can say we have 1 mole substance, and then this is just the volume of 1 mole substance. Or you can use any fixed amount of substance. All right. So over here, let's look at the PT diagram. So if you look at the PT diagram, you need to kind of somehow, cut this. You cut 1 slice at constant molar volume. Or if you want to look at pressure, volume, phase diagram, you need to have a certain temperature, and you cut it. And then you look at the PV phase diagram. All right. Oh, by the way, here, it's the critical point. So above the critical pressure, above the critical temperature, so you'll see this supercritical fluid.